Moving on to Chapter 1, Section 5. Solving equations with variables on both sides. So up to this point, my variable has always been on one side, correct? It hasn't been on both sides of the equation. Today we're going to see how to handle an equation that does have a variable on both sides of the equal sign. Okay? So solving equations with variables on both sides. You can write this if you want. You don't necessarily have to. It is in your textbook. To solve an equation with variables on both sides, simplify one or both sides of the equation if necessary. Just like what we did with our multi-step equations, we wanted to simplify first before we did anything else. So I want to simplify both sides of the equation if necessary. That could be combining like terms, it could be distributive property, anything of that nature. Then use inverse operations to collect the variable terms on one side, collect the constant terms on the other side, and isolate the variable. So, still using inverse operations. Can someone raise their hand and explain inverse operations to me? Inverse operations. Yep.
The opposite of
Yeah, you could just stop right there and that would work, right? They're opposites of each other, right? What's the inverse of addition? Subtraction, inverse of subtraction. Addition, inverse of multiplication. Division, inverse of division. Multiplication. Nothing's changed there. We're still using those inverse operations. What's the first thing it tells me to do? Collect the variable terms on one side. Does it say to collect the constant terms first? No, we want to get our variables to the same side of the equation before we do anything else, after we've simplified. Does that make sense? And I'll show you why we want to deal with the variables first and not the constants in some of our examples. Okay? So after you get all your variables to one side of the equation, collect the constant terms on the other side. What's a constant? Does anyone remember? I've said it a few times in class. Anyone remember what a constant term is? A number without a variable. Constant is a number without a variable. So after I get my variables to one side, I want to get my constants, my numbers without the variables, onto the other side of the equation. And then I can start to get the variable by itself. Okay? Are there any questions about any of these steps we're going to be using to solve equations with variables on both sides? Can I move on? Okay, 2 examples here. Solve each equation. It says check your solution. Once again, I just want you guys to focus on solving the equations. 10 minus 4x equals negative 9x. 10 minus 4x equals negative 9x. We're going to follow those steps that were on the previous slide. So, simplify one or both sides of the equation if necessary. Looking at the left-hand side of the equation, is there anything I can do to simplify that? Can I combine any like terms? Can I use distributive property? Anything like that on the left? No. What about on the right side, the negative 9x? Can I do anything to simplify that? No. So once again, you're not always going to be able to simplify. That's why it says if necessary. So, step 1 done. I've checked to see if any side can be simplified. Step 2, we're going to use inverse operations to collect variable terms on one side. And then get the constant terms on the other side. So raise your hand if you think you can give me the step here that would kind of do both of those 2 steps for me. Any ideas what I would need to do here? Anyone want to give it a shot? Even if you're wrong, it's okay. Very good. I'm going to add 4x to cancel it out over here and bring it over here to the right-hand side. After I do that, what's left on the left-hand side? 10 equals negative 9x plus 4x gives me what? Negative 5x. Everyone okay with that? Are all my variables on the same side of the equation now? Yes, they're all on the right-hand side. Are all my constants on the other side of the equation now? My numbers without variables? Yeah. They're on separate sides of each other, aren't they? Now, from here, I can start trying to get x by itself. Raise your hand if you can give me the step to get x by itself. By. Say it again.
You divide -5.
Very good. Divide by negative 5 on both sides. 10 divided by negative 5 gives me negative 2. So there's my solution. X equals negative 2. Any questions on number 1? If I did want to check my solution here, what would I have to do? Plug in negative 2 where though? Both of them? Yep. I'd have to replace both x's with negative 2 and then work down both sides of my equation. It should give me a true statement when I work it down. In this case, it does. Does anyone need to see that? You want me to show you checking your solution? All right. Number 2. Negative 2x equals 3x plus 10. Negative 2x equals 3x plus 10. Someone raise your hand and give me my first step here. Thinking about all the steps we need to go through right here. What would be the first thing I need to do? Any ideas? Yep. Neither side of my equation, once again, can be simplified here. So now I'm trying to get the variables to the same side of the equation. So I'm going to subtract 3x. It's a positive 3x, so I've got to subtract it so it'll cancel out on that right-hand side. Negative 2x minus 3x gives me negative 5x. And what's on the right-hand side? 10. That looks familiar. What would I need to do now? Divide by negative 5. X equals negative 2. Just like number 1. Questions on examples 1 or 2? How are we feeling so far about variables on both sides? Always deal with the variable first, get the variable to the same side, then get your constants to the other side. All right, these are a little more complex. Yeah. Number 1, 3 times 3x minus 4 equals 1/4 times 32x plus 56. 3 times 3x minus 4 equals 1/4 times 32x plus 56. Still using those steps to work through our equation here. Raise your hand if you can tell me what to do first. Do I need to go back and show you the steps, or are we good with the steps? Any ideas here? Anyone? I can stand here all day. Yep.
You have to simplify
So what simplification can I do here?
d times 2x.
Yep. You remember what we call that?
Distributed.
Yeah, distributive property. On both sides of the equation, right? On the left-hand side, I can distribute my 3 through my set of parentheses. So 3 times 3x gives me what?
9x.
9x. 3 times negative 4 gives me negative 12. Okay with our distribution on the left. Now on the right, I'm distributing 1/4 through my set of parentheses. 1/4 times 32x would give me what? 8x. 1/4 times 56 would give me 14. Any questions on either side's distribution? We good with the distributive property? Okay. Is there any more simplification processes I can do on the left or the right hand side? Any more distributive property I can do? Any like terms I can combine? Anything like that?
9x, 8x.
Are they on the same side of the equation? No. So when I say combine like terms, I really mean just on that same side of the equation. Does that make sense? So is there anything I can do? No. But I will need to do something with the 9x and 8x. At this point, what do I need to do? Subtract 8x from both sides, right? I'm trying now to get all my variable terms to the same side of the equation. So I can do that by either subtracting 9x to both sides or subtracting 8x to both sides. But what would happen if I subtracted 9x? What would I get in front of the x? A negative 1, right? So I'm going to avoid that by subtracting 8x on both sides. 9x minus 8x gives me what? What? 1x, or just x. I still have my minus 12 equals 14. All my variables are now on the same side of the equation. What do I need to do now? Add 12. I need to get my constant terms to the other side of the equation away from my variable. 14 plus 12 gives me 26. And then I can start isolating my variable, but it's already by itself, so that's my answer. Any questions on number 1? Everyone see how we followed the steps? Are we understanding the steps? Simplify first. One or both sides of the equation if necessary. Get your variable terms to one side. Get your constant terms to the other. Then isolate the variable. Okay, number 2. Same thing. What do I need to do first? Distribute. Got to simplify both sides of the equation. So I'm distributing negative 3/4 to 8n and 12 on the left-hand side of the equation. Negative 3/4 times 8n gives me what? Negative 6n. Negative 3/4 times 12 gives me what? Negative 9. We good with that? Any confusion there? Okay, right-hand side, I'm distributing my 3 through my set of parentheses. 3 times n gives me 3n. 3 times negative 3 gives me 3 times negative 3 gives me negative 9. Everyone, hopefully great with distributive property. Any other simplification processes I can do here? before I start moving stuff from one side to the other? Can I combine any more like terms on either side of the equation? Does the left side have any like terms? No. Does the right side have any like terms? No. Is there distributive property on either side anymore? No. So I'm done simplifying. What would be my next step?
Would you add 6 so you will get a negative, or you will just subtract 3?
You could do either one, whatever you prefer, because either way, I'm collecting my variables to one side of the equation, right? So you can either add 6 in here to both sides, or you could subtract 3 in from both sides. You're going to get the same answer either way. So what would you guys rather do? Add 6 in or subtract 3 in? Add 6 in. If you want to subtract 3 in from both sides, go for it and see if you get the same answer as us. 3 in plus 6 in gives me 9 in. Got a lot of 9s in this part of the equation. So I got all my variables to the right-hand side of the equation. Now what do I need to do? Add 9 to both sides. I got to get my constants to the other side of the equation. Negative 9 plus 9 gives me what? 0. Now, how would I get n by itself? Divide by 9. 0 divided by 9? 0. Can I get 0 as an answer? Yeah, it's just a number, right? I can get 0 as an answer. So my solution to this equation is n equals 0. Question on either of these two examples? Still feeling all right with variables on both sides? Okay. Okay, so this paragraph right here is why we like to deal with the variables first and get our variables to one side of the equation first. Sometimes we have these things called special solutions of our linear equations. So equations do not always have just one solution. An equation that is true for all values of the variable is what we call an identity, and it has infinitely many solutions. And we'll see what that looks like here in a second with an example. An equation that is not true for any value of the variable has no solution. So, if you get your equation down to a variable equals a number, how many solutions do you have there? You just have that one solution. X equals that number, right? Here in a second, we're going to see some that have infinitely many solutions. It means no matter what number I plug in, I get a true statement on both sides of my equation. We're also going to see it to where we have no solution. No matter what number I plug in, I'm not going to get any solution at all. Okay? Any questions about this? So let's see what that looks like with some examples here. Solve each equation. We've got 3 times 5x plus 2 equals 15x. 3 times 5x plus 2 equals 15x. What do I need to do first here? What? Distribute, yeah. We got a number times a set of parentheses. Excuse me, so I can distribute it through my parentheses. 3 times 5x gives me what? 15x. 3 times 2 gives me 6. I still have equals 15x. Okay, I've simplified both sides of my equation. Now what do I need to do? What have we been doing every time up to this point? Say it again.
Subtract 15.
Yeah, I want to get my variables to the same side of the equation. So I'm going to subtract 15x from both sides. What happens when I do that? Huh?
You get 0.
You get 0. 15x minus 15x is 0x, but 0 times any number gives me 0. So, anytime your variables cancel each other completely out on both sides of the equation, does everyone see what I mean when I say that? Cancel each other out here, and they cancel each other out here. I don't have any more x's, do I? All my x's are gone. If that happens, I'm either going to get no solution or infinitely many solutions. Okay? 6 equals 0. Is that a true or false statement? False. 6 does not equal 0, does it? So what do you think it's going to be here? Infinitely many solutions or no solution? No solution. If I get a false statement after my variables cancel each other out, I get no solution, which you can write out. Or we have this symbol, a 0 with a slash through it. That means no solution as well. So this is why we like to deal with our variables first. We like to get our variables to the same side of the equation first. That way, if they cancel out, I can look at the remaining statement that's left over and determine how many solutions it has. Okay? So this one has no solution. There's no number out there that I can plug into this equation to make it true. No matter how many numbers you plug in, no matter what number you plug in, you're going to get a false statement. Does that make sense? No number will work for this equation. Questions on A? Okay, letter B. Negative 2 times 4y plus 1 equals negative 8y minus 2. What do you think I need to do first? Distribute. Negative 2 times 4y gives me
Negative 8y.
negative 8y. Negative 2 times 1 gives me negative 2. And I still have everything on the right-hand side. Both sides are simplified as far as they'll go. What's next? I could try to do something, right? I could try to get my variables to the same side. How would I do that? Yeah, add 8y to both sides. But similarly to A, what's going to happen? They're going to cancel out on both sides of the equation. So, boom, my y's are all gone. Completely canceled out on both sides. What do I have left on the left-hand side when they cancel out? Negative 2. What do I have on the right-hand side when they cancel out? Negative 2. So once again, after your variables cancel completely out on both sides of the equation, I've got to look at that remaining statement. Negative 2 equals negative 2. Is that true or false? True. Negative 2 equals negative 2 all day long, right? So, is this going to be no solution? No, it's going to be infinitely many solutions. If you want to put IMS, I'm okay with that. Infinitely many solutions. No matter what number I plug in here, it's always going to give me a true statement. Okay? So it's got an infinite number of solutions that make it correct. So you'll only, like I said, you'll only get no solution or infinitely many solutions if your variables cancel each other completely out on both sides. If they don't cancel each other out completely, you'll get one solution. That variable equals that number. Does that make sense? Any questions or confusion on these special solutions that we have? Good? Can I move on? So here's just the steps again that we went over. Step 1, use the distributive property to remove any grouping symbols. Step 2, simplify the expression on each side of the equation by combining like terms. go ahead and write that in there. Step 3, collect the variable terms on one side of the equation, and then the constant terms on the other side. Step 4, isolate the variable. Step 5, check your solution. Are there any questions over any of the steps we went over or any examples we went over? Good? All right. Here's your assignment. Page 35, numbers 4 through 26 evens. 4 through 26 evens. Things like 12 problems. If you don't finish in class, it'll be due Wednesday the 30th on Canvas. Yes. Here in a second, yeah. Are there any questions about the notes before I end the recording?